Good morning, good afternoon, good evening, depending on where you are in the world. My name is John Aziz, and I'm a Gold Microsoft Learn Student Ambassador, passionate about full stack development and AI. As we go through this, if you have any questions, feel free to go ahead and ask them. One thing to note is that as we go through this, if somebody asks a question, I may hold off for a couple of minutes to answer that, either to try to keep with the flow or because we are going to answer the question a little bit later. But please don't be shy and don't be afraid at all to ask your questions. Now, what we are going to go through is to do a walkthrough of how you might run this presentation and workshop to help you become familiar on how to deliver it. And before we get started, I want to thank Lee Stott for giving me this opportunity. And so let's go ahead and get introduced to Git and GitHub and version control. So what are we going to do today? We're going to get to know what is version control, and we are going to install Git together. And we're going to work on a local repository locally. And we're going to go through and work with remotes on GitHub. And finally, we are going to work on another developer's repository. So let's start by answering this question. What is version control? To answer this question, let me tell you a little story. Once upon a time, there were two friends playing a game. This game consisted of the world map and the small pieces that you use to conquer a piece of land. Sorry. Each player starts by moving his piece, and the player that conquers the biggest piece of land wins. The game takes a lot of time as the players are trying to conquer the whole world. So sometimes they pause the game and continue playing next day. And instead of resetting the game each time, they thought of a nice solution, which is to keep track of the game state by taking an image of the game board each time they stop playing. This image has three things included in it: the time, when they took the image, who took the image, and the state and location of each game piece. And this image ensured that they are gonna always have a safe point to get back to. This concept of a safe point is the idea behind version control. As we keep track of different versions of our code, which might include the time, the person who created this version, and the state and location of our code in the folders. So this is the idea behind version control, which is the idea of a safe point I can get back to of a version of my code. So to sum it up, there are two types of version control systems. The first type is centralized version control system, and the second one is distributed version control system. And in a centralized version control system, only one device has everything. But in a distributed version control system, each device has the same version of the code. So in the centralized, each device has his own piece or its own piece of the centralized code that is found in a centralized repository that is located somewhere. And each device or each person working on a specific device is working on a specific piece of the code. So no one or no device has the full code, only the centralized location has it. And each and every one of the devices is working on a specific piece of the code. But in a distributed version control system, the devices, all of them are contributing to the same code at the same time. all the devices has the small centralized repository, or you can call it the whole code. And this means that all of us are working together on the same version of the code. So there is no centralized location that has all the code in it, but instead, all of us are contributing to it at the same time. The most popular version control systems are Git, Subversion, and Mercurial. But what is the difference between them? As I told you before, the centralized and the distributed version control system is a concept. So that is not a tool that I can use. I can't use the centralized, I can't use this distributed. But these are concepts that we have some tools like Git and Subversion built on, and Git uses a distributed version control system, and Subversion uses a centralized version control system. But again, when we mention Git, which is a distributed version control system, that means that all of us, when we are working on Git, we have the same version of the code. There is no centralized repository that I'm pushing my code or that has all the code in it. But we might mix between two things here. So it's worth mentioning that Git is a version control tool, while GitHub is a service that hosts, and we can use it to store and share our code on the cloud. So GitHub is a version, it's a platform that can be used to save our code and store it in a place that can be shared with anyone because it's on the internet. It's a cloud service. But Git, on the other hand, is a tool that we can manage versions with. When we are using Git, we don't have to use GitHub. But when we are using GitHub, we have to have a Git repository to host it on GitHub. You can't use GitHub to host any type of code. You have to use it to host Git code or Git repositories or Git projects on GitHub. So there is a big difference here. We don't have to use GitHub to work with Git, but we have to use Git to work with GitHub. Moving to the next slide, there are lots of terminologies out there that we might hear about when we start to learn about Git and GitHub, like version control systems, merging, branching, source code manager, repositories, repo, staging area, index, staging index, working directory, remote, merge conflicts, checkout, commit, SHA, and it's a lot. All of these terminologies are actually used while working with Git, but you don't need to learn about all of them at the beginning. But if you prefer learning about everything before starting the practical part, this Git cheat sheet is perfect for you. You can go to this link provided by GitHub itself, and you can learn about all of these terminologies and many more, as it's a cheat sheet that has all the information you need to know about them. So let's get started with our first exercise today, which is to install and configure Git. In this exercise, we are going to download and install Git online, and then we are going to perform the first time configuration for Git, and then we are going to configure Git with our code editor. So let me change my share screen and share my entire screen so you can see with me. Okay, perfect. So this is the repository that we are gonna be working on, that has our workshop. It has the slides, it has the steps, it has all the information you need to know about this workshop. So to get us started, the first step, as I told you, is that we are gonna install Git. To install Git, we have to go to git-scm, which is source control manager, I think. And then we're going to go to the downloads page. So let me just copy this link and go online to download Git. So just paste the link, you can click on it, and then choose the version. So if you are using Mac, obviously choose this, Linux choose this, and Windows just choose this. And I'm gonna click on Windows, and it says click here to download the latest. So I'm gonna just click here. And the download will take 1 minute. So you can do this in your workshop. You don't have to ask people to install Git as a prerequisite to the workshop. Rather, go through it, explain each step in the installation process, but note something very important here, which is that if you start installing Git, it's going to uninstall Git from your device. So that is a thing that happened with me while trying to run this workshop for the first time. I downloaded Git, I tried installing it, and when I started installing Git, it uninstalled my version of Git. So I don't know a workaround for this. Maybe start fresh or just uninstall it. It's perfectly fine to uninstall Git and then reinstall it. It's not going to take much time from you. So if you have Git already installed and you try to install this, it's going to uninstall Git and it's going to restart the installation again. So you make sure, let me just open it, that you don't go through with the installation unless you want to continue it till the end, because you have to go through the installation, the full installation. You can't just click on next, and then assume that it will work. So again, it asks you to accept the license and just accept it and click on install and just follow, okay? Follow the normal installation for Git. You don't have to choose any different options from the default ones, but please make sure that you don't change any options while installing Git, and make sure to instruct your attendees to not install or to not change the options while they are installing it. And the workshop is built on the default options. So if they change something, they might not be able to go through the workshop. So the instructions can be found in the slides, and we can also find them here on the Git repository. So we're going to start with part 0, install and configure Git. So here you can see on Mac or Windows, you can follow these steps, and you can see here we are telling the attendees to install Git while choosing all the default options. Let me just do this. I don't know if I can. Yep, I can. Perfect. And let's do this. Perfect. Okay, so now on Linux, just open a terminal and run this command to install Git. And now the next part, which is to configure Git. The first step to configure Git is to go anywhere on your PC and right-click and choose Git bash here. Or just open it from the start menu, search for it, and you can find Git bash. So there are two different things, Git GUI and Git bash. And what we are going to work with is Git bash. So now, the first command to get us started is to set the global username for Git. So here, we are just telling Git, this is my name. And again, Git, this is my email. And we are going to using the flag global to make this change propagate globally. We don't want to set it for this session only. We want this to be saved forever inside Git. That in the configuration, the global ones, the user.name is for example, John Aziz, which is my name, and for the user.email, my email or your personal email. You can copy this and put it inside your terminal, and it's gonna work like that, or sorry, like that. So let me just close this and open another one. So again here, let's type it. I think it's gonna be better if we type the command. So we said it's git config. So git config, git, change your configuration, but not any configuration, the global configuration, and set the user.name to my name, which is, for example, John Aziz. And again, git, edit your configuration, but not any configuration, the global configuration, and set the user dot email to whatever your email is. But I'm not gonna type my email here because this is gonna be recorded. So that's it. You just tell it to set these two things to make Git identify you and know who is making the changes. You remember what we said about Git at the beginning, that it saves the changes. Again, another thing, which is to make sure that the output that Git gives back to you is colored. We can see that this is already done. All the outputs are colored here, but just to make sure that it works, we are going to tell it to edit the color.ui and make it auto, and this is going to make the output of Git colored. So again, Git, edit your configuration, not any configuration, the global one, and make the color.ui auto. That's it. Now we're going to set up Git with our code editor. If you are using VS Code like me, you can use this command for VS Code. If you are using Atom, you can use this command. If you are using any other code editor, you can go online and look for the command for your code editor. So again, just asking the global configuration of Git to change or to set the core editor to code-wait. So let's do that. Git config the global one to core code, I think, the editor. Let me check, was it core or code? It was core, yep. So core dot editor, and we're gonna set it to code-wait. And just like that. Now we want to see all the configuration options that Git have. So we say git config --list, not all, sorry. So we say git config --list to get all the configuration options that Git already have. So as you can see here, we can see that there is something called core dot. I think it's going to be at the end, so let's skip it for now. So your name here, this is the name that we set. This is the email, and the core.editor is code-wait, and the color.ui is auto. So all the options have been set, and we can review them by typing the command git config --list. Summary, now we have successfully installed and configured Git. Let's practice working with a local repository. Before we go to this, let's learn about working with local repositories. Again, if you prefer to display the commands from here, feel free to do that, but they are found here and they are found on the other repository. So to start working with a local repository, these are the things that we are going to do together today. So we're going to create a Git local repository. We're going to make some changes to this local repository and commit them. And we're going to review the repository history. So to get started, we are just going to initialize a GitHub repository. And this is repeated by mistake. So let's delete it and start again. So from here, to initialize a local repository, we just have to type git init. And these are some of the commands that are going to help us while working with local repositories. So as you can see here, on your local machine, create an empty folder. So let's do that. Let's create an empty folder on my desktop. So new folder. And we don't have to name it anything specific, just create an empty folder. And then if you go back here on GitHub, you can see the next step is to right click inside the folder. And this is really important, inside the folder. Don't right click anywhere and select the git bash here. So let's do it, selecting git bash here and just type git init. And this will initialize a git repository. It's that simple to work with Git. So just type git init. Ta-da! We have initialized a Git repository. All the versions or the times, who did the changes, the seat and location, all of that is saved inside this .git folder. And this is a hidden folder that you can see by editing the settings of here from the properties, I think. No, from the options. So by editing the options here, you can show hidden files to see this file. This file is normally hidden. You can't see it, but it saves everything that is related to Git. And this is how you initialize a Git repository, a local one. So the next step is to make some changes. So to make some changes, we are gonna use the same git bash session that we opened together, because you want to make people familiar with using the command line tools, not just working with VS Code, but to make them learn something that is gonna benefit them so much while working with Git. So we're just gonna touch to create a new file and then start to open this file. And we're just gonna add some text to it and save it. That's it. And these are some very useful commands that we can and you can learn about. So again, let's try to touch new dash text dash file.txt. As you can see, when you use this command, this file has been created inside the folder that we are inside. But what if when you type this command and hit enter, you couldn't see the file? What should you do? Here, you need to know which working directory are you inside. So you are going to use a command called pwd to display the current working directory. And it says that we are inside the new folder. We are inside the correct working directory, which means that everything we are creating will be created inside this working directory. So now we are going to use the command start to open this new text file and add some text to it. Hello from Git. Okay, and just save it and close it. Now, before we get to the next part, you need to learn about an important thing, which is how Git works. So to get you started, you have 3 different places or virtual places. So we have the working directory, which we have just created the file inside, and we have the staging area, which is the place, the intermediate place between saving the changes forever in the local repository or bending or making them in an intermediate state, okay, before saving them to the local repository. So to get started, we have created the file inside our working repository. Now, what can we do to ship our changes to the staging area? Okay, so imagine like you have a voyage and you're going somewhere on a ship. So the first step is to load the ship with your luggage or your bags. So to load our ship with our files, we use a command called git add, and then we give it the name of the file. So for example, we can say git add new text file.txt. It's gonna move our file to the staging area or the staging index, which is the intermediate place between saving everything and shipping it to our local repository, or doing what? Or adding the changes. Maybe there are some mistakes. We want to make them go back to the local repository, so to the working directory, and we don't want to commit them to the local repository. So in order to do the next step, which is to move our file to the local repository, I have to use a command called git commit. Git commit moves the file from the staging area or the changes in general to the local repository to make our changes saved in the Git history or the Git version management system. So to make the changes saved there in the local repository, we use git commit and we give it a message. For example, any message you want. It doesn't have to be a specific message, but there are some rules when using or when committing your changes in the message to use while typing a useful message that helps someone review your code later, that we're going to get to later today. But for now, we are just going to say that there is a command we use, which is called git commit, and we give it the -m small to specify a specific message. And for example, here we are saying it's a message inside a double quotation, and then the file is saved in the local repository. Again, git add, we can use this command two ways. So for example, the first one, which is to give it the name of the file only, git add, and then the name of the file that has been modified, or the name of a file and another file beside it and another file beside it, and so on and so forth. Or if we are gonna add all the changes to the staging area, we can use git add dot. If we add a dot after the word add, and then a space and then a dot, it's gonna save all of our changes. And git commit, as I told you before, it moves, okay, or it changes to the local repository, and we want to always try to write our commands in an imperative way, and there is a do's and don't to keep the message short, less than 6 character, and to explain what the command does, not why or how. So we don't want to write an essay in our git commit message. We just write what this commit does. Does it fix an error? Does it add a new feature? Does it address something in our code? And don't explain why the changes are made, or explain how the changes are made in your git commit message, or use the word and. If you are using the word and, that means you have done so many changes that you need to separate them in two different git commits. So the first git commit has, for example, add new feature X, and the second git commit has add new feature Y. So we don't say in one commit in the message, add new feature X and Y. That is so not preferred to do. So let's see, how can we do this together? So again, as I told you, the first command that we are going to type, which is git add, and we tell it the name of the file, new text file dot txt, or we do git add dot, and then we do git commit dash m, and then we, for example, initial commit, or we can give it a better message like add a new text file, and then we are now committed all our changes inside what? Inside the local repository. So now we can review the history of our local repository. And again, on GitHub, you can find more information about the git add dot, or how to commit, or the next step, which is to review the repository history. There is a command, okay, that can help us to review a repository history, which is git status. And this command is gonna give us absolutely nothing. Why? Because, let me show you. So it says on branch main, nothing to commit, working tree is clean. So it gave us no information. But that's because this command gives us the changes that has not been committed yet to the working tree, or to Git, or to the local repository. So in order to see something useful from this command, maybe I have done some changes, but I don't know what have I done. I have done so many changes that I don't know which files have been changed. What am I working on right now? So I can do a git status before committing the changes to see what has been changed. But for us, let me show you, before we commit the changes, it should have showed us this. No commits yet, and there are some untracked files and untracked changes that you need to commit and to add first, to track the changes, and then to commit them. So let me, for example, show you how to do it. Again, we're just gonna open the new text file, hello from Git, and version control. Just add some changes and save it, close the file, and go back to your terminal and do a git status. So now it tells us there is a file. It has been modified. It's the new text file. You can either git add or git commit. So again, we are gonna git add the changes, but we are gonna use the dot this time, and our changes have been added. And then we are gonna git commit. We are gonna say edit, okay? The first sentence. I don't think, that's totally fine. Okay, now we can run git status again, and it will give us that on branch main, nothing to commit, and the working tree is clean. So the next step here is to do what? To see the history of the repository, okay? This is a really important difference between the get status and the next command, which we are going to review together. So get status doesn't show you the history of the project. It shows you the current changes that have not been yet committed to the working repository. So how can we see the history, the changes that has been done previously? We can use a command called git log. And let's get back to the slides because it's displayed better there. So again, get status, get log, and again, get status, and it doesn't show us the history. It only shows us the working directory and the staging area. And again, git log, which is a very important command because this command will show you the history of changes in the repository. And these changes include something called the char, the author, the date, the commit message. So what are these things? If you go back here, you can see that the char is a unique ID for each commit you do create. It will have this char to identify it from other commits. And the author is the email and username we have configured together with Git at the beginning. And the date is the date and time of the commit. And the commit message is the message that we have added when you committed our changes. So let's see it together. Let's just type git log. And now you can see the char, the author, the date, commit message, char, author, and email, date, commit message. That's it. So we can see all the changes that has been done to our repository, and we can see why I told you to use good commit messages, because this is what identifies your different changes. If you don't use a good commit message, you don't know what happened here at this specific time. What did John do in the repository? I don't know. So in order to help each other while we are working, we need to use a good commit messages. Again, there is another command to, if we have a very big repository that has lots of changes, we can use this command to display them in a better way, which is git log one line. So we use the command get log to display the history, but we add the flag --1 line to make the changes, all the changes in one line, only the char and the commit message. So we have the char, the commit message, we can see all the changes that has been done to a specific repository. Now, congratulations, you have just used Git to create a local repository and manage your projects. Now you can work with Git locally on all your projects. So let's move forward to the next step, which is working with remotes. To get us started while working with remotes, I think we need to review something here first, which is what we are going to do. So in this exercise, we are going to create a GitHub repository and clone it together. And we are going to make changes and push these changes to GitHub. And we are going to fork a repository and make a pull request. So let's get started with creating a Git repository. So the steps are here. They are fairly simple. From, if we go here, you can see there is a plus sign, and you can choose it to create a new repository. And just give it a name and save. That's it. We have created a new repository. It's fairly easy to work with Git. And again, to create this repository, we are going to name it Hello World. Okay. And we can add a description to the repo. So let's just copy it and follow the steps one by one. So now, as you can see here, after we create this repository, we are going to clone it. So let's start by creating the repository by going here. Like I wanted to save this somewhere. So let's just open this in a new tab and go back here because we want the steps, obviously. So let's just see, here. And then here, you can say here, you can choose the owner, you can choose the repository name, which is Hello World. And then the names are important, guys, because the steps are built on these names. So if you let people name the repository anything, you're going to have to tell them specifically that they have to do this command, but change a specific thing in order for it to work for them. So now we are creating a new repository, and we have named it Hello World, and we can get the optional description, which is my first repository on GitHub. Let's just get it, that's okay. And we can optionally choose to add a README. We are not going to do that. And you can optionally choose to add git ignore and the license. And you can learn more about these stuff from these links. We are going to get to this. And we are not going to get to this today. So now just click on create repository and you have the repo ready. The next step while working with repository, okay, is to clone your repository. Okay. So to get us started, let me just go back here. And we should have chosen to initialize the repo with a readme. So let me just get back to the repo and let's create a new file and just name it readme.md. Okay. I think it's like that. Can't remember. Let's just name it like that. It's not going to make a difference. Okay. So commit it. So again, you don't have to do what I have just done. I just forgot to create my readme. So I created it manually. So for you, while you are creating your repository, just check the box that says create readme. And now the next step is to clone the repo. How can we clone it? And cloning a repo means to download it locally. So you can work on it on your local PC. So we can't see the button that says clone because, yep, now we can see it. And now, when you go to the repo page, you can click on code. And from here, you can choose the way that you want to clone your repo with. We are going to clone it with HTTPS using a command called git clone. And the command that is called git clone does lots of things. So what does it do? It takes the path to an existing repository, and by default, it will create a new folder on your PC, and the name of the folder will be the same name as the repository being cloned, and it can be given a second argument to be used as the name for the repository, and it will create the new repository inside the current working directory. So if we go here inside the git repo that we created locally, and we say git clone, and now we give it this command. Sorry, again. Okay, it says that the protocol is not supported, so we can't clone it with HTTPS. So we are just going to use the HTTP. Okay, I think there is another error. Let's go to the repo again and copy the link. Okay, and go back here and do a git clone. And okay, now it is cloning the repo. And if we go to the folder, and before we go to the folder, let's use a command from the commands that I have told you about before, which is the ls command. And now you can see there is a hello world folder created inside this folder. And if we go back here, we can see it. And if we enter it, you can see that this is also a Git repository. So it's a Git repository inside a Git repository. So now, the next step is to obviously make some changes. So if we go back here, we can cd to hello world from our terminal, and we can echo to create a new file, okay, and add this text inside it. And then we can add it, commit it, and use a new command, which is called git push. So let's do everything, but hold off on the git push command because I want to tell you a little bit about it. So I'm just going to go to the new folder, and now we can see that we are inside the new folder. And we can also verify this by using the command bwd, and we can use the command clear, and again bwd, we are inside the correct folder. And the next step is to do what? Is to make some changes. So let's use this command, which is called echo, to create a new file and add this text to it. So again, into our git bash, we are just gonna do echo some text and then the name of the file to be echoed on site. And then we can see there is a new file created, and we can use a command called cat to see the content of the file. And you can see the content of the file is my first sentence on GitHub, and we can start this new file to see the content of it again using the command start, and you can see the content is my first sentence on GitHub. We are just verifying things and reiterating the commands that we have learned before together. And we are gonna add our changes, to move them to the staging index, and we are gonna commit our changes. Let's say this is the initial commit, okay? And we're just gonna git push. This command is gonna do something very cool that you are gonna learn about in the slides. So let me share my present. So let's go to slides, show, and present from current slides. So again, how Git works, but now with GitHub. There is something new that has been introduced to us, which is the remote repository. The remote repository, which is in our case GitHub, can be used to host our code online. So I can ship my code not just to my local repo, I can ship it online to the cloud to share it with others, either in a private repository or in a public repository, which is open to everyone for contribution. And in order for me to move my code from the local working directory on the local repository to the remote repository, I have to use a command called git push. Let's push our code. Sorry, I have muted myself by mistake. So we can just type git push. So we can just type git push, and as you can see, the file has been moved to GitHub. So what if it's the other way around? I have done some changes on the remote repository, and I want to get them locally. I want to see the changes I have done on the remote repository. I can use another command called git pull, and git pull will take the version of the repository that is hosted on GitHub and download it to your local repository. So let's see this in action together. So again, you guys, we have used git push, and this have pushed the changes to GitHub. And to see our changes, we just have to hit the refresh button. Whoa! The new text file is now hosted on GitHub, and it has our changes, and you can see the commit message beside the name of the file. So what if we did the other way around? We have some changes on GitHub that we want to get locally. We can do edit to the readme, and maybe, for example, let's write hello world. Let's make this, okay? And then let's type, for example, some changes, okay? And now I can commit these changes, give them a commit message, and just hit commit changes. And now, what do I need to do to get these changes to appear locally? To get them to appear here in my folder. If you open this file, you can't see anything inside it. It's empty. So in order to get the changes, we have to do what? To pull the changes from GitHub. So let's use a command called git pull to get the changes from GitHub. And you can see there is a file that has been changed. It's called the README, and it has 2 new lines. So let's see the lines here inside our README. Woo! Now we can collaborate. Someone else can clone our repo and push his changes to it and get the changes locally by git pull from the GitHub repository. And what do we need to do? The next step we need to do here is to contribute to someone else's repository, for example. So to learn about this, we can visit this repository, and we are going to do this together by opening the repository in a new page. And then in the top right corner, you can click on fork from here to take or to have your own copy of a specific repository. I'm not going to be able to fork my own repository because it's my repository, so I'm not going to be able to fork it. But you can fork it on your own, and attendees of your workshop can fork your own repository, and then we can clone it locally using the steps we have already learned together. So for example, we can go here and do a git clone for a specific repository. And now I can cd inside this new repository, and I can open it in VS Code, for example, and I can add my name to the list of contributions. Okay, so again, I can do John Aziz again, just to show you how you might normally do this. Okay, and just add, oh my God, just add a new line. Okay, and save, and close this, and let's go here and do a git add dot, and then git commit my name, and then git push. Okay, now we have made some changes to this repository. The normal thing that someone might do is to create a pull request. So we can go to pull requests here and click on new pull request. And from here, if we have some changes, we are going to have a page displayed for us to start our pull request, and we can add the title of the pull request, and that's the only thing we need to do, to add the title for the pull request. For example, your name and then contribution, and then select a button at the bottom of the screen that says create pull request. And congratulations, you have successfully created and cloned a Git repository, and the repository you created can be shared with anyone. And this enables collaboration and so many great things that happens on GitHub. So if you want to continue learning, you can go to this link to learn about GitHub on Microsoft Learn, and you can go to this learning path to learn about version control with Git. So again, I don't want to just leave you at this. Let me just make a pull request. So in order to make a pull request on my own repository, I just have to create a new branch, and let's call it test branch. Okay? You don't have to do this part, but I'm just doing this to show you how you can make a pull request. So I'm just going to create a new branch. And inside this test branch, I'm going to make a change. Okay. So for example, I might go here and remove this. Okay. And then I can commit my changes. And going back here, I can click on, you can see here, there is a button that says you can create a pull request. But we're not going to follow this button. We're going to click on contribute and then choose open pull request. And then, as I told you, you have to add the title. So for example, I told you that you can add your name. So John Aziz contribution. And then you can add here a description of your pull request. And you can click on create pull request. And then someone else, it might be John, for example, reviews this pull request. So let me just review it. Okay. Review changes. And I can't approve my pull request. So someone else can approve your pull request. And once it's approved, someone else again can merge this pull request. And as you can see here, if we go back to the main branch, you can see that our changes has been reflected here. And that's it. Merge pull request from John Aziz test branch have been reflected on our main repository. So again, thank you so much for attending this Train the Trainer workshop. And I hope that you enjoyed it. And if you have any feedback, don't hesitate to reach out to me so we can improve this workshop more and more. And you can go to this feedback survey link. It's aka.ms workshop omatic-feedback. And you can submit your feedback there about all the workshops that found on the workshop library. Again, thank you so much and see you in future events.